Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the SQL Channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein, and I'm a PL/SQL developer just like you. This lesson is part of my series on effective management of PL/SQL-based applications. And the focus of today's lesson, or this lesson anyway, is compile time warnings. So Oracle 10G was a big release for PL/SQL. Besides lots of new features, Oracle also completely rewrote the underlying compiler technology, demonstrating its long-term commitment to the PL/SQL language. So with Oracle 10G, we now have an automatic, transparent optimization of our code, and that's covered in the previous lesson in this series. We have compile time warnings that help you improve the quality of your code. And we have conditional compilation, in which you get to decide what code should be compiled, what code should be ignored, a very interesting feature, which I cover in the next lesson in this series. But in this lesson, let's talk about the compile time warnings framework. Warnings, basically advice, help you build better code. So you write your program and you get it to compile without errors. Okay, you can run the program, but the question is, how high quality is that program? Does it fully leverage the PL/SQL features? Is it running as fast as it could? Are there ways to improve its readability and maintainability? Now, various tools give you ideas on how to improve your code, and books, of course, will do that as well, like my Oracle PL/SQL Best Practices book for a quick advertising plug. But you can also ask Oracle to give you advice about how to improve the quality of your code. And this is what the compile time warnings framework is all about. Now, before we dive into all the details of the different warnings and how you turn it on and turn it off, all the warnings that are available in PLSQL are shown in the error messages manual, which is available online. And all the warnings start with a PLW prefix. Let's take a look. I'm going to visit my favorite online documentation site for Oracle, tahiti.oracle.com. You can also go to docs.oracle.com. Here's tahiti.oracle.com. The reason I like this one is it's written entirely in PLSQL. This is a PL/SQL application using mod PLSQL. You can search for individual phrases, but you can also drill down into various books of documentation. So I'm going to click on the 11G Release 2 documentation set. And then in the top left, you'll find the error messages book. And you can check out all the different error messages that Oracle has defined. Obviously, you're familiar with the Ora-0 for no error, Ora-1403 for no data found, etc. And if you look at the PLS category, you'll find all the PL/SQL compile errors. So that's what PLS means. And the PLW are the warnings. And you'll find lots of different ideas here, or different examples of what Oracle will do to analyze your code to improve its quality. And we're going to look at a number of these different warnings today. But you should go ahead and take a look through this list of warnings and decide which ones are most important to you, which ones you want to apply in your environment. And there are increasing numbers of them. With every new release, Oracle adds new warnings. So do check out the online documentation and the error messages manual. So, the compile time warnings framework. First of all, to use the compile time warnings, you have to turn them on for your session or for a particular program unit. By default, warnings are disabled, and this is quite different from automatic optimization, in which optimization is enabled by default at a very high level. So you get optimization automatically. You do not get warnings automatically. And you have great specificity in how you can define which warnings you want to see by individual numbers or by categories. So here's an example of where the general statement would be alter session, enable or disable, and we'll come back to the error category in just a moment. And then I can say enable all, enable just severe warnings, enable information warnings, performance related or specific warning numbers. So here's an example of the simplest way to turn on all warnings in my environment. Just enable all, and that's for my session. Here's an example of setting a PL/SQL warning setting for a particular program unit. I want to set for this procedure, alter procedure, my procedure, set PLSQL warnings equal to, well, I'm going to enable the 6002 warning. I'm going to enable all the performance warnings. and I'm going to specify that I want the 5005 warning to be treated as a hard compile error. Now I'll come back to the details of what this means and how to do it in just a moment. The point is that you have a lot of flexibility about how you specify the warnings in your environment. How do you check for warnings? Well, essentially, when you compile a piece of code and you get a compile error, Oracle will write to the user errors data dictionary information about your hard compile errors. It will also write compilation warnings. So if you're working in SQL+, which would still be kind of sad, but if you compile your code in SQL+, you can use the show errors command to display the errors and the warnings. Inside IDEs like Toad, the warnings will appear in the window along with the errors. And of course, if you wanted to, you could write your own select statement against user errors to display this information. But by and large, any place you would see compile errors, you will also see compile time warnings if warnings are enabled. Let's take a look at some examples and explore this functionality. First of all, let's take a look at one of the most important kind of warnings that we could do, which is a check for unreachable code. So I write a program with hundreds, maybe thousands of lines of code, and I've run some tests and it looks pretty good. But it could be that there are whole chunks of code in my program that are never ever executed, theoretically impossible to execute. And it's very hard for us to find those things ourselves. Now with a simple program like this, it's no big deal. I can look at this program and say, well, X is was defined with a default value of 10, which means it will always execute this line of code. But hey, it's never going to execute line 7. That's an unreachable line of code. Yeah, so we can look at this program and we can figure that out. But when you're talking about hundreds and hundreds of lines of code, this could be pretty hard to figure out. No problem. Oracle will do it for us. So let's check out the PLW 6002 script. Now in general, if you look at the demo zip that you download, all the PLW files will give you examples of different warnings. Not every single one of them, but some of them that I found most interesting. And I'm not going to demonstrate all of these in this lesson, but a number of them. So 6002. I'm going to create a procedure called PLW 6002. I assign a value to a Boolean variable, etc., etc. Rather than explain this code, let's run it. Let's alter my session, turning warnings on. I'm going to compile my code. And let's take a look at what I get in my messages section. Notice it says compiled with 0 errors and 3 warnings. So this is how it's manifested inside Toad. Of course, it will work differently in each different IDE. And I've actually gotten 3 different warnings. PLW 5018, unit PLW 6002 omitted the optional auth ID clause. Default value was used. Default value of definer was used. What this warning is telling me is that I could have, and I should have explicitly listed my auth ID definer clause. If I don't explicitly list the auth ID clause, then it does pick up the default of definer, and the alternative is auth ID current user. Now, most PL/SQL developers are not aware of and do not use the auth ID clause, which is called invoker rights or definer rights. And so what Oracle is doing is reminding you, you really should include it there, and the reminder of the default value of definer. Moving on, 6006. This is pointing to my subprogram called Why Did I Write This? And it's reminding me that you never called this program, Steven. I defined it and I never used it. So what it's telling me here is it's removed. The optimizer has actually removed this program from my compiled code to reduce the size of the compiled module. And it's certainly never executed. Finally, 6002. It's pointing to this line of code and saying this line of code will never run. Why not? Because L checking is defined a default value of false, assigned a default value of false. This is never true. This never executes. So that's an example of a very powerful warning that would be very difficult for us to do ourselves. Sure, we can remember that we should have an auth ID clause, though of course we won't. We'd probably notice if we looked at our code closely that we created this subprogram and it never got executed. But finding these lines of code in our subprograms that for some reason or other will never be executed can be very tough, and Oracle will do it for us automatically. Okay, so that's one really great example. Let's take a look at another one. This is added in Oracle 11G. And that is handling one of my long-standing frustrations, and for a lot of developers a frustration, which is that Oracle doesn't complain about this code. This code will compile, even though it's clearly too big for the container. And then when I run my code, I'll get a numeric or value error exception, an ORA -6502. And you look at this code and you think to yourself, why doesn't Oracle figure that out for us? Why doesn't it warn us? And in Oracle 10G, they didn't, for some reason, implement this warning, though I think it would be one of the more basic and obvious warnings to do. But that's okay. It's finally addressed in an interesting sort of way in Oracle 11G with the PLW 6017 warning. So Oracle has added a warning called 6017, an operation will raise an exception. It's a very generic category of a warning. It basically says this line of code is going to cause you a problem. It doesn't actually tell us what the problem is. For example, that it's going to raise a -6502 error because it's too small. It's a more generic exception or warning. And that's, I suppose, the plus and the minus. The plus is it'll handle or warn us about a variety of circumstances, which we're going to look at in just a moment. The downside is it would be nice if it gave me a really specific warning. Steven, your value is too big. Let's take a look. If I can only type. So, what I'm going to do here is create a procedure, PLW 6017, and I'm going to assign a value to a variable called C, and it's too big, and I'm going to declare a number variable, and I'm going to divide it, I'm going to assign a value to it, dividing by 0. I enable warnings in my sessions. I compile. And I get a warning. Or actually, what I'm getting here, interestingly enough, is a syntax check from Quest itself, from the IDE. It's looking at this code and saying, Steven, I'm not going to compile this for you. It's actually stopping compilation, which is kind of amazing, and I don't like that. But it's saying, go no further. You've got a problem. Your string initializer has a value which is too long. So here's an example where the IDE, the integrated development environment, my editor, is actually giving me more information than the compiler is going to give me. And that's really nice. But of course, different tools work in different ways. And I want this tool, I want the underlying Oracle framework to tell me that I've got a problem. So let's get around Toad's wonderful trapping of the error. Let's start up a session in SQL+. And let's take this code out and run it there. So again, I alter my session, turning on warnings. I compile my program, and notice, procedure created with compile time with compilation warnings, not errors. And now I write show errors, and it shows me. On line 4, an operation will raise an exception. So it's telling me, this code is going to be a problem for you, Steven. So check it out and fix it now. In addition, line 7. Now this is interesting. It's giving me 2 warnings, unreachable code, and an operation will raise an exception. So let's look at line 7, the second warning. It's saying, Steven, you're going to divide by 0. We know that's going to cause a problem. As for the unreachable code, I'm actually not sure why that's showing up there. And what you'll find when you work a lot with the warnings is that you'll get interesting results that sometimes don't make a lot of sense. And it usually has to do with the interactions between the optimizer and the compile time warning system. The only reason I can think that it might say that line 7 is never going to run, well, I guess is that this is going to raise an exception. That makes sense. Line 4 raises an exception. This code will never be encountered. It will never be run. So, fairly sophisticated analysis there. So that's 6017. Very nice addition to the suite of warnings. And again, that's not in Oracle 10G. Let's take a look at some new compile time warnings in Oracle 11G. So 6009, the exception handler does not re-raise an exception. So this warning is really valuable because a common problem that developers sometimes have is they essentially write the equivalent of exception when others then null. Swallow up my error, I don't care, just keep on going. And 6009 will give us a warning when that happens. I'll come back to this comment here in just a moment. 7205, it'll warn you about mixed use of integer types. So if you're using the new 11G simple integer, and you combine it with PLS integer or binary integer, that can cause some problems in terms of performance and also conversion. And Oracle's warning us about that. Unnecessary assignments. I did an assignment to a variable that's not required. Lots of warnings related to the new inline optimization level 3 in Oraclellg. And then more feedback on the impact of optimization. So this is the one I showed you. Notification that entire subprograms were removed, also added in 11G. Let's take a look at the PLW 6009. So I'm going to turn on my warning enabling this specific warning, 6009. And notice I've got a function that raises an exception or traps an exception when others and returns a string. Here's a version that re-raises the exception. Here's a version that raises an exception with raised application error. And here's a version that hides the raise inside another program. So essentially I have a generic utility that will log the errors and re-raise them. And I'm calling my program here and then doing the raise here. And let's take a look at what the impact is of this warning for each one of these. So I set my warning on for 6009. I compile this program and I get a warning. And it says, Steven, your others handler does not end in raise or raise application error. You're not re-raising the exception. Now, I would argue in this case that's okay because it's a function I want it to return a value in this case, but at least it's giving me the warning telling me that it could be a problem. Let's try it again after compiling, or I'm going to compile now with a raise. No more warning. Compile with a raised application error. No warning. That's good. And now I'm going to compile my subprogram raise in here, and then create a replace function 6009. And now I get the warning again. And this is one of the problems with the 6009, the limitation of the 6009 warning. It's very common, and in fact I recommend strongly, that you use a shared reusable utility to log, handle, and raise errors. So I would usually have something like my Quest Error Manager, raise unanticipated, and then some values here. So this is how I would normally want to write my program. And unfortunately, even with this architecture, which is definitely the best way to do things, oops, now it told me that it had no warnings. Interesting. Maybe it's better than I thought. Let's see if I say return null. Interesting. So it's telling me now that it does not end in raise or raise application error. But if I simply end it with a subprogram, it doesn't give me the warning. Let's see if that's true for any subprogram. So dbmissoutput.putline. Compile. No warning. Well, this is strange. So again, as I mentioned earlier, sometimes it's hard to understand the logic behind how they analyze their code and do their warnings. For some reason, this is not raising a warning, whereas this did raise a warning. And I don't understand why that would happen, except that, well, when I run this program and get down to here, this would raise an error because I'm not returning a value. Okay, so that's the logic here. It either returns a value or Oracle detects that it's going to raise a value. So, sorry, raise an exception. Let me go back over this with you. My apologies for the confusion. The return here, this raises the warning because I'm returning it a value. So the function will complete successfully, but I did not re-raise an exception. I swallowed up the exception. In this case, it detected that I did re-raise, so it said, fine, you raise the exception. In this case, it has a return at the last statement. So even though I have a raise application error, well, in this case, let's see. In this case, it didn't give me the warning because I did re-raise, even if I do have a return afterwards, because this return is never going to execute. In this approach, when I called raise in here, and then did a return, well, now I get a compiler. In this case, it gave me a warning because it did not end in raise or raise application error. But if I take this out and simply call a program, it's not going to warn me now. Not because this program has a raise inside of it, but because when this code runs, Oracle says, well, I know that this is going to raise an error one way or another because it doesn't return a value. So either it's going to raise its own exception or Oracle will raise an exception for us. So that's what's going on with 6009. Let's take a look at 7206, unnecessary assignments. So I'm going to enable all warnings. I'm going to declare a variable. I'm going to assign a value to it. And then I'm not going to be using lvar. Let's see if this will raise the warning. And notice here it says I've got a 5018. I omitted auth ID, but otherwise it didn't warn me. So even though I declared the variable, I assign a value to a variable, and I don't use it afterwards, it's not giving me the warning. Let's see what happens if I assign it in the default value, and I never use it in my block of code. Nope, still not giving me the warning. So here's an example of a warning which says that there are, if we go back to the documentation and look for 7206, analysis suggests that the assignment to string may be unnecessary. The optimizer could not find any further use of the variable which was being set. So in this case, for some reason, Oracle's not determining that it should raise the exception or raise the warning. I don't know why, but that's what 7206 should be doing. There must be some other interaction going on that's causing it not to raise the warning. And maybe you'll find a circumstance and counter circumstance where it might occur. Let's see. How about this one? So again, I'm not actually able to find a circumstance that raises the 7206 warning. Maybe you can find a circumstance that would work, but that is the documented warning from Oracle. Let's finish up by looking at how to treat a warning as a hard compile error. You might identify a warning that reflects such a bad coding practice that you want to ensure that it never makes its way into production code. And so you can do that by setting the warning as a hard error and stopping the use of that program in its tracks. Nobody will be able to use this program unless they fix the problem reflected by the warning. And I think a prime example of this is function does not return value. In other words, I wrote a function that's so badly designed that under some circumstances it doesn't even return a value. Now, here's how I can do that. Alter session, set PL/SQL warnings, error 5005. Treat the 5005 warning as if it were an error. Let's take a look. So first of all, I'm going to define a couple of functions that my other function will call. I'll try running that function. Let's just do it to demonstrate the runtime error that I want to avoid. I run my code and I get function return without value, or 6503. Now I think this is a terribly embarrassing error. This is the sort of thing I never want to see happen at runtime because it shows that I defined my function very poorly. So my function terminated without raising an exception and also didn't even return a value. Yuck. How did that happen? Well, usually it happens when I have multiple returns in the same function. And this is a recommendation or a bad practice that I talk about in writing maintainable code. I talk about having one way in and one way out to a function. There's one way into the function by calling it. There should be one way out, which is a single return on the last line of my program. That's how I can fix the problem. So return a value that I set in my function. But in this situation, what I've done is define multiple return points. If this is true, then return this. If this is true, return that, etc., etc. Oh, and look, here's a branch that does not have a return in it. Now again, with a small program like this one, I can eyeball it and figure out what's wrong. In a large function, a large complex function, it may be a lot harder to figure out where the return is lacking. So let's try it again. I'm going to alter session, turn on warnings. I'm going to recompile my no return function. And now I get two warnings. Yes, I get the good old warning auth ID clause is not present, but more importantly, 5005, my subprogram returns without a value. So Oracle automatically detected that there's a branch of logic in which a return will not be executed. So I want to avoid that problem, and I want to avoid it from ever happening in production. So what I'm going to do now is alter my session, set PL/SQL warning, setting 5005 to be an error. In fact, before I do that, let me just go back one more time, run this again, and remind you that warnings are PLW 5005, PLW 5018. Okay. Now I'm going to alter my session, and set my 5005 to an error, and then I'm going to recompile my function. Success with compilation error. Okay, it's not going to show me the specific warning, so let's do a full recompilation from my code. And it tells me that I now have an error. Notice PLS, not PLW, PLS 5005. Same message, but now it's a hard error. I cannot use this program. I cannot run this program. It is invalid until I fix the problem. So that's the value of the error signifier for warnings. You can specify basically a series of quality control checks, not only to improve the quality of code, but to make it impossible to run that program unless the error, which is actually a warning, goes away. So watch out for false negatives and nuisance warnings. I think if you've seen, the behavior of the warning subsystem can be surprising. It can require you to really think through what's going on, and in some cases you just get a lot of additional information you really don't want to see. So, for example, the check for a couple of things to look at. The check for unreachable code, the negative 6002 warning, is not very useful prior to 11G. It will actually show you lines of code that always execute as never executing because the optimizer has taken them out. They've been optimized out, for example, a null statement. They've been optimized out, and then the unreachable code analysis says, hey, where's this code? It's gone. That means it can't be executed. So the 11G unreachable code analysis is much better than 10G. In addition, you might often be overwhelmed by warnings you don't really care about, like the missing auth ID clause. Sure, theoretically, it'd be really good to do that. It'd be really good to put an auth ID clause in every single. Sorry, let's go back to setting my sessions to enable all. Let's get back my auth ID clause warning. Yes, it might be good to be reminded about this all the time, but if you're working in an environment where the auth ID definer clause is unnecessary, you're not using invoker rights, well, you might not want to see that warning all the time. You might want to get a clean compilation every time you compile your code. No warnings, no errors. So you might want to avoid these kinds of nuisance warnings. And also, as you can see, with things like 7206, sometimes it's just really hard to understand what are the circumstances that cause the warning to be raised. I hope you didn't mind looking at 7206 and having me fail to actually bring up the warning. I still have not been able to come up with the circumstances that causes the warning to fire. So maybe I wasted a little bit of your time, but hopefully you also saw that it's of some advantage to just simply go exploring. Try out these different warnings yourself with some samples of code, see what works in your environment, what doesn't, what is most helpful, and what isn't. Conclusions. You definitely want to take full advantage of all the compiler offers to help you build the best possible code. The optimizing compiler is clearly something you're going to leverage over and over again. The warning subsystem can be of enormous assistance as well. So review those available warnings. Go to the error messages manual. Look at the different warnings. Ask yourself, which of these are really, really important to me? Which are the ones I always want to check for? Which are the ones I could ignore and in fact want to ignore because they keep bothering me? And then you might consider setting up special scripts that enable different sets of warnings to match different development scenarios. For example, if you're building an application that uses invoker rights, auth ID current user, then you might want to insist that every program unit has the auth ID clause set, whether it's definer or invoker. You might have another set of scripts for a different application in which you have certain warnings that are set to be errors, and so on. And of course, you can then ignore the nuisance warnings. You can disable certain warnings like the 5018. And if you take the time to set up these various scripts and apply them in your environment, you'll be getting much more information and much more assistance from the Oracle compiler than you ever did before, and the resulting code will be cleaner, will be faster, will be easier to read, and easier to maintain.